Hello everyone, welcome back to my channel. Today in this video we are going to discuss about operator precedence parsing. So first we have to know what is operator precedence grammar. A grammar is said to be operator precedence grammar if and only if the following conditions are satisfied. So what is the first condition? There should not be any production rule in the grammar which has epsilon on the right hand side. And the second rule says that there should not be two variables or the two non-terminals which are adjacent to each other. Okay, now let us look into this example. In this example, S derives SAS, S derives ID, and there is definition for A derives plus or minus or star or slash. As per the first rule, there is no epsilon on the right hand side. So the first rule is true. What about the second rule? The second rule says that there should not be variables adjacent to each other. But there are variables adjacent to each other. But we can modify this grammar like this and we can convert the grammar so that it becomes suitable for operator precedence parsing. So how do we do that? S derives yes. In place of A, first let me replace it by plus. Then in place of A, let me replace it by minus. Then I will replace it by star. I'll replace it by slash. S slash S. S divided by S. Right? Then S derives ID. That is a rule, right? Okay. Now if you look into the grammar, nowhere on the right hand side of the production rule, two variables are adjacent to each other. So this is operator precedence grammar. And this grammar is suitable for operator precedence parsing. Okay. Now let us see how to build the operator precedence parser. This operator precedence parser, in fact, it covers a small range of grammar, and whichever the grammar contains an operator. The operator can be of anything, relational operator or arithmetic operator or Boolean operators. For such grammar is suitable for this kind of designing this kind of operator precedence parsing. Okay. So what are the steps involved in building operator precedence parser? Step 1, first we need to define a operator precedence table by defining the precedence relation among the terminal. So we need to define the precedent relation among the terminal. What is a step 2? Once the precedence table is built, based on the table we are able to parse the given string. Okay. Now the question is how to define the precedence relation. Let us consider two terminals. One is A, another one is B. I can write A is greater than B when if precedence of A is greater than precedence of B. I can write A is less than B when the precedence of A is greater than precedence of B. I can say A is equal to B if both the precedence of both the terminals A and B is one and the same. So using this only, I have to define the precedence relation, either greater than or less than or equal to. These are the three operators I can use to define the precedence relation. Apart from that, three important points we need to remember. The first thing is, in a grammar, always the identifier is given the highest precedence. And the dollar we normally use to indicate the end of the string, right? It is a right hand marker we can call, or it is sentinel. This dollar is always given the lowest precedence. Identifier is always given the highest. Dollar is always given the lowest precedence. Okay, suppose there are two terminals or two operators are having the same precedence. Then what do we need to do? We have to go by applying the associativity of such operators. Either it can be left associativity or it can be right associativity. Okay, now let us see one example. So this is the grammar, the same grammar which we converted into operator precedence grammar. That grammar I'm going to consider now. Right? Now for this grammar, I'm going to build the precedence table. This is the step 1, right? So to build the table, what are the rows represent and what are the columns represent? It is nothing but the terminal. What are the terminals present in the grammar? Plus, star, minus, slash, ID. All these are the terminals. Apart from that, by default, we need to consider the dollar. Okay, now I'm going to define the precedence relation among this terminal. ID is equal to ID, right? And already I said that ID is an identifier which is having the highest precedence of all the operators. So ID is greater than plus, ID is greater than minus, ID is greater than star, ID is greater than slash. ID is having greater precedence than dollar also. Okay, now just to consider this column. Now every symbol is being compared with ID, right? If you compare every symbol with the ID, its precedence is always lesser than the precedence of ID. So plus is having lesser precedence, minus, star, slash, dollar. All these symbols are having the lesser precedence than ID. Then dollar and dollar is having the same precedence. Now let us try to fill the other relations. When you compare plus and plus, what is the precedence relation we need to define? Suppose you take an expression like this, A plus B plus C. When you consider this expression, which operation we will be performing first? First A plus B we will be performing and the result will be added with C. Because when there are two operators of the same precedence, we go for left associativity, right? So this plus is having higher precedence than this plus, isn't it? So when we compare the precedence relation, I mean when we try to identify the precedent relation between these two plus, imagine or consider this is the left plus and the column is nothing but the right hand side plus. So this plus is having greater precedence than this plus. If you mark this symbol between the operators of the same precedence, it means you are ensuring left associativity. Similarly, plus and minus are having the same precedence, but we need to ensure left associativity. So mark like this. Plus and star, when we compare, plus is having the lesser precedence than star. When you compare plus and minus, plus is having the lesser precedence than slash. When we compare plus and dollar, plus is having greater precedence than dollar because we know that dollar is having the least precedence. Okay, now compare minus and plus. Both the operators are having the same precedence, but minus comes first followed by the plus, isn't it? So we need to ensure the left associativity. To ensure left associativity, mark this type of relation, that is minus is having greater precedence than plus. Again minus and minus, left associativity, minus and star. Subtraction operation is having lesser precedence than star. When you are writing the precedence relation, always write the precedence relation with the row value, with respect to the row value. Minus and slash, when you compare, minus is having lesser precedence. Minus and dollar, minus is having the greater precedence. Then star and plus, star is having greater precedence than plus, greater precedence than minus. Star and star, if you consider, we have to ensure the left associativity. Even for star and slash also left associativity. Star and dollar, star is having the greater precedence than dollar. Slash and plus, slash is having greater precedence. Slash is having greater precedence than minus. When we compare slash and star, you have to ensure left associativity. Slash and slash also left associativity. Slash is having greater precedence than dollar. Now dollar is having lesser precedence compared with all the operator. Now we filled the operator precedence table, right? Once the operator precedence table is ready, we have to parse the string. So I have considered the string ID plus ID star ID, and at the end of the string dollar is there, which is indicating the end of the string. Okay, now this string is available in the input tape or in the input buffer. What we are going to do now, there is a stack. One more point I want to tell, that operator precedence parser is a bottom-up parser. So what are the actions performed by the bottom-up parser? In general, bottom-up parser performs 4 actions. One is shift, another one is reduce, then accept, or if the string is not parsable by it, it will end up in error. These are the four actions performed by bottom-up parser, of course by operator precedence parser also. Right? So this operator precedence parser is also a type of bottom-up parser. So stack contains dollar. Stack is empty. Now this is the first input symbol read by the parser. Now we need to compare dollar and ID. So this is the symbol available in the input tape or input buffer. Compare the precedence relation between the top of the stack and the input symbol. So when you are comparing, first you compare the top of the stack with the input symbol. This is the order. When you compare the relation, if the input symbol is having higher precedence than the top of the stack, then push the symbol onto the stack. Push is similar to the action shift. Push and shift are synonyms here. Okay. So compare ID. ID is having the higher precedence. So push ID onto the stack. So now ID you can remove from input tape. In fact, you don't need to remove. You just advance the input pointer to point to the next symbol. Okay. Now what is available at the top of the stack? ID is available at the top of the stack. What is the input symbol it is reading? It is reading plus. When you compare these two precedence relation, ID is greater than plus. Just refer to the table. ID is greater than plus. So the plus symbol is having lower precedence than ID. So you cannot push this plus. What do you need to do? You have to pop this ID now. Now you pop this ID. I will write the operation here. Pop ID. So ID is popped out of the stack because the input symbol is having lower precedence than ID. Right? Before pushing this input symbol onto the stack, there should not be higher precedence symbol at the top of the stack. So we popped ID. Whenever there is a pop operation, it is equivalent to reduce operation. Now ID is reduced to, sorry, it is yes. ID is reduced to yes because we have a rule S derives ID. Now this ID is reduced to yes. Okay. Now what is the input symbol? It is plus. What is available at the top of the stack? Dollar. Compare dollar and plus. Plus is having higher precedence than dollar. So push plus onto the stack. Now the input pointer is pointing to this ID. Now compare the top of the stack with this input symbol which is having the higher precedence. ID is having the higher precedence. So if the top of the stack contains lower precedence, above that we are able to push the higher precedence symbol. So this ID is also pushed onto the stack. Now the input pointer is pointing to the next symbol. What is available here? Star is available here. Now compare top of the stack and the input symbol. Input symbol is having lesser precedence than the top of the stack. When this situation occurs, pop. So now ID is popped. When this ID is popped, automatically reduction happens. Now this ID is also reduced to S. So what is available at the top of the stack? Plus is available. Compare this plus with the current input symbol which is star. Star is actually having higher precedence than plus. So we can push star onto the stack. Okay. Now input pointer is advanced to point to the next symbol in the input buffer. So what is available here? ID is available. Compare star and ID. ID is having the higher precedence. So push that ID onto the stack. Push is equivalent to shift operation. Already I said that. Okay. Now input pointer is pointing to the next symbol. Isn't it? Because this ID is pushed, shifted to the stack. Now input pointer is pointing to the dollar. Now compare the top of the stack and this dollar. Top of the stack is having higher precedence than the input symbol. So this ID is to be popped. Whenever there is a pop operation, there is a reduction operation. So ID is reduced to yes. Okay, now what is available at the top of the stack? Star is available. Compare the star with this input symbol, what it is pointing to. So what it is pointing to? It is pointing to dollar. Star is having higher precedence than the dollar, isn't it? So when the top of the stack contains higher precedence than the input symbol, then the star is to be popped. So now star is popped, right? Now you see, when the star is popped, now yes and the star and this yes, all three symbols put together is reduced to yes, because we have a production rule, yes derives s star s. So now parser have identified the handle yes star yes. Now this perfect handle is reduced to yes now. So this is what happened now. Now the star is popped, isn't it? So what is available at the top of this track? Plus is available. Compare plus with a dollar. When you compare plus with a dollar, top of this track is having higher precedence. So pop plus also. When we pop plus, now again parser identified another perfect handle, which is yes, this plus and s. Yes plus yes, and this s plus yes can be reduced to yes. Now what is, yeah, we have the rule s derives s plus s. Now this s plus s is reduced to s. Okay. Now what is available at the top of this track? Dollar. What it is pointing to? Dollar. When you check what is dollar and dollar in the precedence table, it is the having the same precedence level, and of course it reached the end of the string also. That's how the parser stops. If you look into the parse tree, how this parse tree is built? The parse tree is built from the string to the root of the parse tree. So operator precedence parser is a bottom up parser. You people can try with some more examples in the similar way. Since I remembered the precedence relation without referring to the precedence table, I have just entered. You can refer to the precedence table and you can do the parsing in the same way. Thank you, students.